Okay, so we're going to do vector valued functions, so VVFs, and integration, which is slightly more useful than the derivative, in that we're going to be able to get things like arc length and curvature out of this concept. So realistically, this is actually pretty straightforward. It is R of t is some f of t, g of t, h of t, so that f, g, and h are continuous almost everywhere. So this is a little bit of a kind of a restriction that's used from time to time. It basically says that the functions have to be continuous, but the discontinuities that exist, if there are any, have to be of size 0. So they have to only exist over one point. The reason why this is that integration is ultimately calculating the area under a curve. And if I get rid of one little strip of that area, then, so like it's area under a curve, and if I get one little strip, the area here and the area here are still going to sum up to the entire area. So this is why I can kind of hold back from requiring complete continuity, and I can have continuity but with discontinuities of size 0. Okay, so that's where we're getting the continuity almost everywhere. So they've given that the definite integral from a to b of r of t is just taken component-wise. It's the same as the definite integral from a to b of f of t dt. There should be a dt here. Sorry, dt. Right. Is the integral from a to b of g of t dt, and the integral from a to b of h of t dt. So you're literally just taking the 3 component integrals. So another important note, because all of the limits are component-wise and the derivative is component-wise, the fundamental theorem of calculus still holds. So if r of t is the same as, if r prime of t, big R prime of t, is the same as r of t, then the integral from a to b of little r of t is equal to big R at b minus big R at a. So if you take the derivative of big R and you get little r, then we are basically saying that if you're taking the integral of little r, should be dt, then it's the antiderivative of r at b minus the antiderivative of r at a, which is what we understand as the fundamental theorem of calculus. And it just carries over from real valued functions to vector valued functions, and everything still works. So integration is integration. Things like u substitution and biparts and all of that good stuff still work. So there you have it. All right, thank you.